Going to talk about triangle and two transversal proportionality theorems today. Today we're going to prove and apply the triangle and two transversal proportionality theorems. So these are our big idea 3 is formal proofs about triangles, and so today we are going to talk about triangle proportionality theorem, which is part of 4D IOA. So the triangle proportionality theorem states if a line is parallel to a side of the triangle and intersects the other two sides, then it divides those sides proportionally. So what does this mean? It means that if I told you this was 1 here and this was 2 and this was 2 over here, then this would have to be 4. Okay, so that means that AE over EB is equal to AF over FC. Okay, so that's what we're going to do in example 1. So it says find US. Well, the first thing we have to see is, do we have a pair of sides that are parallel? We do. CVU is parallel to TS. So what I'm going to do is I'm going to draw a line right here where UV is, okay? So that you guys can see that we've got RU over US. And that's going to be equal to, on the other side, RV over VT. Okay? Now what we're going to do is substitute in those numbers for those variables. So we've got 14 over US is equal to 10 over 4. So hopefully you remember we're going to cross multiply here. Okay? So we're going to do 10 US right there. And that's going to be equal to 14 times our 4. So that's still 10 US. And I move the screen down, equals 56. So how many times does 10 go into 56? Divide both sides by 10, right? So that's going to be US is equal to 5.6. Now we can check this, okay? So our 5.6 goes up here, right? Okay. So we're going to check it by making sure that these ratios are the same. So 10 over 4, that's equal to 2.5. And what is 14 over 5.6? If you put that in your calculator, that also equals 2.5. So that's the way we can check and make sure that our answer is correct. Okay? So now we're going to do this U-try together. So here again, I always look to see, we see that we have two sets of parallel lines, right? So LM is parallel to PQ, okay? So that's what's going to now create our ratio. So we're going to use that again. It's like our dividing line. So we're going to do 3 over PN, and that's going to be equal to 2 over 5. And I just set it up exactly the way the problem looks. So once again, we're going to cross multiply. So that's going to be 2PN is equal to 3 times 5. So 2PN is equal to 15. So divide both sides by 2 again. So PN is equal to 7.5. And again, if we want to check it, we can do 3 over 7.5. And 2 over 5 and see if they're the same ratio. All right, let's go ahead and you guys go ahead and do this last one and find X for me. And that's not what it says on your paper, so make sure that you actually solve for X right here, okay? Come back to me when you're done. So on this one, I'm going to do 2 over 6 is equal to X over 9. That's 6X is equal to 2 times 9, 6x equals 18, divides both sides by 6, so x equals 3. So once again is 2 over 6, which is equal to 1/3, equal to 3 over 9, which is also equal to 1/3. Yes. Remember, that's the way we check it. Okay. So for this next example, it says find UW. So it's asking us to find this whole side right here. Well, to do that, since I don't have the same sorts of sides, and notice again we got parallel lines here, so there's my dividing line, right? So I'm going to find WV first. I can find this UY right here, UY, by doing what? 45 minus the 27. So when I do that, I got 18 right here, okay? So now we can do 30, what is that, 12? Sorry, I can't read that on my paper. 12 over VW is equal to 18 over 27. Now, once I solve for that, then I can solve for the whole side because I can just add the parts together, right? Okay, so 12 over VW, so that's going to be 18 VW is equal to 12 times 27. And 12 times 27 is 324, so 18 VW is equal to 324, divide both sides by 18, so VW is equal to 18. So that's 18 right there, and this again was 12, okay? So 18 plus 12, so if we're looking for UW, that's going to be equal to 12 plus 18, so UW is equal to 30. And again, 12 over 18, is that equal to 18 over 27? That's what you're going to check, just to make sure. Now, I want to show you something a little bit different with the next problem, and we can do it a different way because we now have the same types of parts. So see right here, here's again, that's parallel to DE's parallel to AC, right? Okay, so we could say 15 over 24, so 15 over the whole side, so that left part of the triangle. So we could do this over here too, 25 over our question mark. That's what we're solving for this time. And again, that's not what it says on your paper, but that's what it should be. So this is going to be 15 question mark is equal to 24 times 25, right? So 24 times 25 is 600, so 15 question mark is equal to 600. Divide both sides by 15. So our question mark is going to be equal to 40. Okay, so this over here is 40, so then what would EB be? Now we could have solved for EB, right? Or could we have? No, we couldn't have this time, could we? Why? Because we don't have the bottom part, do we? No, we could have, actually, because we could have subtracted, right? So 25 from 40 is 15, right? And what would DB have been? 15 from 24 is 9, right? Okay, y'all see that? So again, we could have solved for EB, and then we could have solved for the long part. But I wanted to show you that there was another way to approach that particular problem. All right, so go ahead and do the U try 1B. Okay, on this one again, we have parallel side, right? So I'm going to do 15 over question mark equals, and what is 14? 4 from 14, that's 10, right? So we're going to do our 10 over our 4. So this is going to be 10 question mark equals 15 times 4. So that's going to be 10 question mark equals 60. Divide 10 into 60, and our question mark is going to be equal to 6. So is 15 over 6 the same as 10 over 4? That's your question to double check and make sure your answer is right. All right, this next one says converse of triangle proportionality theorem. So this says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So this time what you're proving is that if AE over EB is equal to AF over FC, then the lines are parallel, okay? So we're going to determine if DE is parallel with BC right there, okay? So what we're going to do is I'm going to do 10 over 15, and that's, see if that's equal to 8 over 12, okay? So 5 goes into 10 2 times, and 15 3 times, 4 goes into 8 2 times, and 3 times. Now there's another way to do this. We could cross multiply, right? 10 times 12, does that equal 15 times 8? For those of you that don't like to reduce, this is another way. This is 120, and this is also 120. So if those are equal, then yes, DE is going to be parallel. whoops, wrong symbol, y'all, is parallel with BC. Okay? All right, let's see if you guys can do the you try. Come back to me again when you're done. So once again, we're trying to determine if AB and DE are parallel, right? So, and it says AC this time is 36. So if AC is 36, then AD is 16, right? It says that BC is 27. So 15 from 27 is 12, right? So here we're going to go 16 over 36. Is that equal to 12 over 15? So, 16 over 30, no, why did I do 16 over 36? Whoop, yep, okay, there we go. 16 over 20, right, y'all? 16 over 20, okay. So 4 goes into both of those, so that's 4/5. And 3 goes into both of those, so that's also 4/5. Yep, so it does check out. So we can say that AB is indeed parallel with DE here, because the ratios are the same. Okay? So this next one says the two transversal proportionality. So if 3 or more lines intersect 2 transversals, then they divide the transversals proportionally. So this says AC over CE is equal to AB or BD over DEF. So once again, if I told you this was 1 and this was 2 and this was 2, then this would have to be 4, right? Okay, so we're going to do this down here. So we're going to take GH over HJ, right? See that? And we're going to do KL over LM. Okay, so that's what we're going to do. So we're going to do 8 over 6 and 10 over RX. So once again, see, this is our dividing line right there, okay? So that's 8x is equal to 6 times 10, which is 60. Divide both sides by 8. So when you divide both sides by 8 there, you get 7.5. So again, our check here is 8 over 6. Is that equal to 10 over 7.5? Now you can just put those in your calculator. When you do, you get 1.333. Is that equal to 1.333? It is, okay? So go ahead and do this you try right here and come back to me again. X over 8. There's our dividing line. Equals 15 over 10. 10x equals 8 times 15. Don't know that one off the top of my head. So 8 times 15 is 120. So 10x equals 120. So that means x is equal to 12. So once again, is 12 over 8 equal to 15 over 10? Double check that in your calculator, okay? All right, this next one says find y, and then over here find x, okay? So once again, we have our parallel lines, right? So we can create a proportion. So y over 9, is that equal to y plus 5 over our 12? We're going to cross multiply here. So it's going to be 12y is equal to 9 times y plus 5. Distribute that y, that 9 to both y and 5. So this is going to be 12y equals 9y plus 45. Subtract 9y from both sides, you get 3y equals 45. So y is equal to 15. So that means that would be 15 right there, and 15 plus 5 is 20. So is 20 over 12 the same as 15 over 9? That's what you want to check, again, in your calculator. All right, go ahead and do the you try 5 and come back to me when you're done. I'm doing 9 over 6 is equal to x plus 4 over 8. Cross multiply again, so we're going to do 6 times our x plus 4 equals 9 times 8, that's 72. 6x plus 24 equals 72. Subtract the 24 from both sides, that gives me 6x equals 48. and 6 goes into 48 8 times. So here again, 8 plus 4, so that would be 12. Is 9 over 6 the same as 12 over 8? That's how you double check to make sure your answer is correct. So here's our last one. It says, suppose that an artist decided to make a larger sketch of the trees. In the figure, if AB is 4.5 and BC, so all these trees are going to be parallel, okay? So if the trees are parallel, then we can say that 4.5 over our 4.9. I'm going to do this problem a little bit different than I've done the other one. Now I could do it over the 2.6, but I'm going to do the ratio that I can see. So I'm going to do this side over that side. So we're going to approach this problem a little bit different than we have the others, okay? Because we're going to use that ratio with all the rest to solve for LM and MN, okay? So that's going to be equal to our 2.6 over our LM. So here again, we're going to cross multiply. So this is going to be 4.5. LM is equal to 4.9 times 2.6. So 4.9 times 2.6 is 12.74. So we got 4.5 LM is equal to 12.74. And then we're going to divide 4.5 into 12.74. So LM is going to be equal to, and it says round to the nearest tenth of an inch. So that's 1 decimal place. So that's 2.8 inches. Okay, so that's LM. Let's see if you guys can solve for MN. So we're going to do the same ratio, 4.5 over 4.9, and that's going to be equal to, this time, our 4.1 over our MN. Okay? So when we cross multiply this one, it's going to be 4.5 MN again is equal to 4.9 times 4.1, so that's 20.09. Divide 4.5 into both, so MN is going to be equal to 4.5 inches. Okay? Alright, see if you guys can do the you try over there on the right. You try 4 and come back to me when you're done. So 2.4 over 2.6 is equal to 1.4 over our LM. So this time we got centimeters. 2.4 LM is equal to 2.6 times our 1.4. That's 3.64. So 2.4 LM is equal to 3.64. Divide both sides by 2.4. So LM is equal to 1.5 centimeters. Okay, let's see if you guys can do the last one. If you haven't already done it, pause the video, come back to me when you're done. So here again, we're going to do our 2.4 over our 2.6, and that's equal to, this time, our 2.2 over our MN. So this is going to be 2.4 MN. 2.6 times 2.2 is 5.72. Divide both sides by the 2.4, so MN is going to be equal to 2.4, and again, that's centimeters.